Okay, there we go. Um, so why wouldn't everybody have an IBM computer with IBM chips in it? Because we don't make computers for the average person anymore. We used to at some point, but now all of the computers we make are for large businesses. So if you find IBM a set of IBM power chips or a set of IBM mainframe chips, they're usually going to be in a large bank at the core of a government. I have a government client who has been running an IBM power server to do their payroll for the entire government. And they've been doing it since like the 80s, and it's the same server. I bet, and I saw it. They keep it in a corner of the server room on the ground, and basically it's cornered off like a police do not cross line around it. It's like this thing is continuing to work. Nobody touch it. But IBM stuff is known for being extremely reliable, extremely robust. There's a legend of IBM computers that have been bricked up in walls accidentally, and they continue to function. And then when people, they were looking for it, and then they had to tear down the wall, and they found it, and it was still going. So that like I said, that may be a legend. I don't know if that's true or not, but I for myself have seen something that continues to run the payroll for government. I think they only started to get off of it last year, and it was running since the 80s. Anyhow, Apple also makes chips. The present computer that I'm presenting on now is an Apple computer. And Apple has started making what they call M1 and M2 chips, the Apple M chips. I'm running an Apple M1 chip on my laptop, and it is, everyone has said, is a significantly better experience than Intel chips. I can basically agree. Why not? Why doesn't everybody have Apple computers? Because they're expensive. So, my workplace mandated that I must have one, so I have one. But outside of that, you don't necessarily need to have one, but it runs really well. It really does. Then there are phone and tablet CPUs, which are specific to phones and tablets. Qualcomm makes phone and tablet CPUs, so does Samsung, so does Broadcom, and a few other manufacturers. But the typical CPU you will find around the place, especially in a computer, will be an Intel or AMD. Okay, then moving on to the next slide. So RAM, or random access memory. This is the short-term memory of the computer. So when a computer is working on something, working on a spreadsheet that you are calculating stuff on, working on a game that you are playing right now, working on a presentation like what I'm showing you, the computer wants to be able to access that quickly, right? So it stores that in a short-term memory area so that it can pull at it quickly and present it to you, all right? That is what is called the random access memory, or RAM. When I turn off this presentation and I'm done, it is going to forget everything that it has seen. So it does not store this information. It just uses that short-term area so it can show it to you quickly. And then once it has finished doing what it's doing with that piece of information, it forgets it, gets rid of it. The advantage of RAM is that it's very fast, all right? And that's what it needs to be able to show you things quickly. Most devices will count RAM in gigs or gigabytes. And just for reference, I don't need to go into this in detail, but just for reference, 1 gigabyte of RAM is about 1,000 megabytes of RAM, which is about 1,000 kilobytes of RAM. 1 megabyte is about 1,000 kilobytes. 1 kilobyte is about 1,000 bytes. So 1 gigabyte of RAM is like, I don't know, what is that? Like a billion bytes of RAM, basically. So we usually count it in gigabytes. And most devices will have at least 4 gigabytes of RAM. Typically, 8 is good. Nowadays, 8 is good. Most will have 4. 8 is good. 16 is great, 32 is legendary. For your home devices. If it is a device that's being used for, as a business device, not a computer that's on your desk, but the computers that are in the data center and the server room and so on and so forth of your typical business, they will have multiples of 16. So they'll have 32, they will have 128, they will have 96, they will have 512 gigs of RAM, etc. The RAM comes in sticks and it looks kind of like this. That's the picture. It's basically a stick. The motherboard has slots that you put the RAM in, and those pins, those metal pins at the bottom of the stick, that's what goes into the slot. So you put the RAM in the slot, and that's it. RAM is good to go. Usually, each motherboard will have 4 or more slots. Sometimes it'll only be 2, depending on the motherboard. But each slot can hold a certain amount of RAM, and the motherboard will tell you how much RAM each slot will be able to hold. So, yeah. Now, let us go. So that's the short-term memory. Let me go back. CPU, brain. RAM, short-term memory, very fast. Storage. Now, as I said, the computer forgets what it is, what it has been working on in short-term memory immediately after you stop working on it. So it has to store information somewhere. And we typically call that somewhere like the storage location or storage. This is the long-term memory. This is where the computer puts information it does not want to forget. So when it is finished working on this presentation, yes, it will forget the presentation, but it puts it in long-term memory so that if it needs to pull it to short-term memory again later, it can. All right, so that is the storage location. There are typically 2 types of storage locations for your average computer nowadays, and that is a hard disk drive, which looks like the graphic at the top here, and a solid state drive, which looks like a lot like RAM, which is the small graphic at the bottom there, the last of those 3 pictures in that bottom graphic. The hard disk drive it uses magnetic disks, and it has a little arm like a record player that it moves over the disks like an old-time record player, if for those of you who know what an old-time record player looks like. It has moving parts on the inside. So it will make noise, it'll move, it'll go click, 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 if you listen to it. It is slow by comparison to RAM, by far, much slower. But it is big. RAM comes up, goes up in amounts of 32 gigs and, so on and so forth. The maximum amount of RAM you'll see in a computer is about 32 gigs. Hard drives go up in terabytes usually, which is 1,000 gigs of RAM. So 1 terabyte is 1,000 gigabytes. So you will get a 1 terabyte hard drive or a 2 terabyte hard drive. And the reason why you can get them so big is because they're cheap to make. So they're cheap, so they're bigger. And you can get more storage. This is for long-term storage. Solid state drives are a newer technology. They don't have any moving parts. So as a result, they tend to be more reliable because moving parts will break down over time. In theory, because the solid state drive doesn't have any moving parts, they tend to be more reliable. They're almost like RAM, but they're cheaper than RAM. But they're much more expensive than hard disk drives. So there's a trade-off. They are way faster than hard disk drives. They're much smaller than hard disk drives. They're cheaper than RAM, but they are more expensive than hard disk drives and less expensive than RAM. So a lot of people will have, nowadays, a lot of people will have a big hard drive in their computer, like a terabyte. They may have a smaller solid state drive, like 512 gigs, like half a terabyte. And then they will have, maybe 8 gigs of RAM or so in their computer. And that gives the computer kind of a good balance because the computer will put things it needs to remember in the far future into, the or things that it can afford to put on ice for a little while in the hard drive. It'll put things that it needs right away, but still needs to be a long-term memory in, the solid state drive. And then sometimes it will put, the things it needs immediately in RAM. Eventually, probably RAM will kind of phase out in preference to solid state drives, because solid state drives essentially are the same thing. It's just that they're cheaper. What you will also find is these little cards that you put in your phone. Oh, the bottom graphic. Okay, somebody is asking me about the bottom graphic. The bottom graphic shows 3 drives. There is a hard drive in the back. There is a laptop hard drive in the middle, and then there's a solid state drive, just to show you the difference in size, really. What you will find nowadays also, though, are these little cards that you put in your phone, for storing data as well. Those are also solid state, and they're very small. USB drives are also solid state, and you see how small they can be. So solid state has been around for a while, but it's becoming more and more popular because it's becoming more and more affordable. Now, moving right along. I just thought I would mention, since I had to touch on USB just now, I just thought I would mention, interfaces just very, very, very briefly. There are different types of ways to connect to a computer, right? And we call those interfaces. I'm just touching on some of the more common ones right now. You will see USB Universal Serial Bus. That is the most common type of interface. And usually, if you look at the top graphic on the right-hand side, you will usually see a USB-A, type A. That's very, very common, and that's the oldest type of USB. And then you will also see a USB 3.0, which looks just like a type A, except it has a blue connector. So if you look at your computer right now, you probably will find a USB type A or a USB 3.0. Another type of connector, which is also very common nowadays, is USB type C, which has an oval kind of plug interface. My computer is a USB type C. Most of the phones that are available now are USB type C. And then there's USB micro, which is the kind of older phone connector that existed. These are ways for connecting to a computer to provide power or to exchange information. Another connector you'll find, which is very common, is HDMI. I did not write down what that acronym means. I apologize. I'll send it to you by email. HDMI is used almost exclusively for video and audio. All right, so that's what that second graphic there shows, an HDMI cable. And then Apple had its own cable type or own connector type that was very popular at some point in time, but is becoming less and less popular nowadays. And that's the Lightning connector, which looks just like the one you've seen there in the bottom graphic. All right, everybody following me so far? This is much more boring than the first day because it doesn't talk about money, or is everybody good? Everybody following? Any questions?
Yes, we follow him. Yes,
no? Okay, great. Let's go. Graphics processing unit, or GPU. Now, remember I said the CPU, everything has to pass through the CPU. That in most computers is true. However, with the advent of, very video intensive games, to be honest, it was video games that made this popular. And other things like computer assisted drawing and people who have to map out GIS surveys of the country, topography and all those things. The need became evident for somewhere or some kind of processor that can handle graphics outside of your CPU. And they said, okay, what can we do here? So they created a second kind of processor called a GPU, graphics processing unit. You will hear it called a GPU, you'll hear a video card, you will hear those types of things. The GPU is a secondary processor that fits into the computer. Most computers do not have a GPU. Most computers will handle graphics using the CPU. But for those that you're going to be dealing with heavy graphics, like computers that are used again for video gaming or computer assisted drawing or whatever, they will come with a GPU. The GPU is a processor all by itself. So it runs hot. It runs even hotter than the CPU in most cases. And therefore it has its own fan and cooling apparatus. So if you look at the little box above, the RTX 3090, that is one of the more modern GPUs. It has a built-in fan. It has its own RAM so that it can do its own processing with its own high-speed short-term memory. And it will have 2 gigs, 4 gigs, 6 gigs. Nowadays, the more powerful GPUs will have 8 or 16 gigs of RAM. And they're very, 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 very expensive. They're very expensive. Even more so now, because people have found that GPUs work really well for certain types of hacking and certain types of accessing, generating Bitcoins and cryptocurrency. So, and there is a way to automatically generate Bitcoins and cryptocurrency. It's something called crypto mining. I'm not going into it today, but GPUs apparently do it very, very, very well. So people who are making a lot of money on crypto mining have bought up all the GPUs in the world, essentially. And therefore, it's driven the price of GPUs way up into the air. So GPUs are even more expensive than they used to be because they're kind of hard to come by nowadays. During COVID, there was a complete shortage of GPUs, so that manufacturers could not even make devices that had GPUs in them anymore to a certain extent. It was pretty serious, all because of crypto mining. So anyhow, that's a GPU. Moving right along. Sorry, I see a message in the thing. Okay, cool. Motherboard. So I'm talking about all these things. But if you get all of these things, a GPU and some RAM and a CPU and some storage, and you put them in a bag and shake them up, you will not have a computer. You will not, because they cannot connect to one another. You have to wire them to one another somehow so that they can talk to one another. That is what the motherboard does. A motherboard wires everything together. It provides wiring between the CPU and the RAM and the storage and everything else. That's basically the purpose of a motherboard. And that wiring is called a bus. So that the bigger the bus, or the bigger the space on the cable, so to speak, because each cable has an amount of data that it can carry. The bigger the space on the cable and the wiring within the motherboard, the more information it can carry. You really don't have to care about bus sizes nowadays. It really doesn't make that much of a difference. The bus is usually big enough to handle anything that you put in it. But as I said, motherboards are kind of designed for individual CPUs and GPUs. So when you buy a motherboard, you have to make sure that your CPU that you're going to put in it, or GPU you're going to put in it, will fit. All right. I have two illustrations of motherboards here. I just want to point a couple things out. If you look, you will see like a square in each of those illustrations. And on the right-hand side is brown. On the left-hand side is gray and silver. That's where the CPU goes. There's always a square in the middle that you can find, or a square that you can easily find that you put the CPU on. That goes there. Off to the left on the black motherboard, you'll see like 4 long, slim slots. And off to the left on the green motherboard, you'll see some slots with some white tabs at the end, black slots with some white tabs at the end. That's where the RAM goes. All right, so the RAM goes pretty close to the CPU, and it's usually on most motherboards in the same position. And then the last thing I'll point out, there are some slots at the bottom there. In the black one, there are 2 slots with white ends on the right-hand side. In the green one, there are 3 slots. Those are where the video card and any other card you want to put in there will go. And it's called the motherboard because, you know, that's kind of the mother of everything. It's like the blood, the what do you call that? The not nervous system. It's like the whatever circulatory system, right? That carries blood throughout the whole body. All the information and power for every single part of a computer is carried by the motherboard. All right, good.
Archer,
Yes, please.
just a question.
Sure.
Is there a vast difference to the motherboards now, per se, those from in earlier years?
Yes, because as I said, each motherboard is designed to handle a specific kind of CPU and RAM, etc. So if you were to try to use a motherboard from, say, 10 years ago, no, the RAM would not fit, the CPU would not fit, it probably would not even be able to fit SSD storage. So the majority of the things you would use now or that are available now wouldn't fit in an older motherboard.
Okay, thank you. I just asked that question within the context of even the chip in the phone.
Okay.
Because that the phones now, the chips are smaller. So if you haven't changed your phone in a long time, you will have to get the chip changed. So that it's in that context why I asked the question.
Oh,
Thank
yeah.
you.
Oh, yeah. No, especially for smaller devices like phones and tablets, they will sell the CPU and the motherboard and all those pieces together. You will never, ever have to change the CPU on your phone. Ever, 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 ever. At least not in my lifetime, probably. Okay. Moving right along. I just want to touch on form factors for a minute, just for 1 second. So when I say form factors, basically the size and shape of the computer. Your phone is a computer. If you have a smartwatch, is a computer. A tablet is a computer. Even the box that you use for your TV, if you got a floor box or a direct TV box or whatever, that is a computer. If you have a PS4 or some kind of video game system, that is a computer. All of these things are computers, and they are going to have a CPU. They're going to have RAM. They're going to have storage. All of these things will exist within them because they're all computers, right? And the rules exist. The rules that I have stated so far maintain for all of those situations. Okay, moving right along. It's just that some are bigger and smaller and different shapes, but that's just a form factor thing. Okay, we're done with hardware. What's the time? Okay, yeah, we're doing all right. We're done with hardware, but I just want to touch on the certifications. Now, I tried to find some free ones. To be frank, I could not find any free ones. Any free certifications or micro-credentials around hardware, not that are worth anything, to be honest. So if you want to do something that's worth something, I would suggest one of these two from CompTIA. Maybe start with IT fundamentals. They provide training, and the training is paid training. So you buy the training from CompTIA. You could buy training from other people too. I used to buy books all the time and teach myself that way. But you buy training from CompTIA. You can even probably get free training online. If you go onto YouTube and search CompTIA IT fundamentals, you probably will get some introductory courses online that way. Use 75 questions in 60 minutes, 72% pass rate for the IT fundamentals, and it's $134 US for the exam. That $134 just gets you the exam. So, and if you fail it, well, that's the $134 up in smoke, basically. So, but it's a learning experience. Then your one step up from that, which is the most popular hardware certification that has existed from years back all to now, is still the most popular, is something called CompTIA A+. They require 2 exams, one on hardware, one on software. It's 90 minutes in total for 90 questions. The pass mark is about 80%. $250 US. per exam. So it's about 500 US dollars. I told you this thing could get fairly expensive. About 500 US dollars for those two. And at the end of that, you kind of have a really good chance of being hired as an IT technician. That is kind of what you will be preparing yourself for if you take those exams. Now, let me come off of sharing screen for one moment and turn on my video. And I want to show you something. Let me make my thing the spotlight. All right, watch it. So I have in my hand a motherboard. This is a motherboard for a small computer called a Raspberry Pi. Let me bring it a little closer to this camera. It's not very big. You see my fingers by comparison. My hands are not very big. This is what the motherboard looks like. I just wanted to show you some of the parts just for your own benefit. This is the CPU right here, this little black thing. I can't take it off. And because it's so small, it doesn't have a chip. Sorry, it doesn't have a fan. But this is the CPU. This is the HDMI slot that I told you about. All right. It has some USB-A slots over here. And then it has a networking port, which we'll talk about next time, RJ45 networking port. So it has the CPU, it has the HDMI for video, it has, so what is missing in this? Anybody want to tell me? All right, somebody said the RAM, my wife is next to me so she can hear me. Said the RAM is missing, so watch this. So what they did was, they got this little card, like the same card you put in your phone, and this is the RAM right here. This is the RAM and the long-term storage all at the same time. It's solid state. And you could take it out or put it back in. Much like how it works with a phone. I can't do that looking at this phone. but just to show you, computers can have very different form factors. This is a whole computer all by itself. All right. All right, great stuff. Moving right along. Let me share my screen again. Give me 1 second. And we're going to touch on software. We have 18 minutes, and I want to give y'all, a few minutes to do a test, because we got to have a test. All right, let me get set up here. All right, here we go. Okay. All right, software. So let's talk about software for a minute. Let me get out of the way. How do I get my head out of the way? Okay, that's better. Software. So I'm going to touch first on operating systems. When you put a computer together, like what I showed you earlier, let me see if I can get this to show up. I cannot. Anyhow, when you put a computer together, like what I showed you earlier a few seconds ago, it really doesn't do anything. At the most, you will get something called, if you boot it up, at the most, you will get maybe a very basic command line, and it can't run anything. It doesn't do anything. It needs something called an operating system, which allows you to operate all of the different parts of the computer. The operating system is the software that gives you access to all of the capabilities within the computer, all right? It allows you to interact with the computer. There are different types of operating system. I have in the graphic here above, some of the types of OS. There's Windows, which you know very well, made by Microsoft. Most of you are running Windows on your computers. There's Linux, which is popularized by this little penguin. If you ever see a penguin on the internet, most IT folks will know that they're talking about Linux. There's Apple, which is pretty well known. I'm running an Apple Mac right now. There's Android. Most of you who have phones, smartphones, know this symbol. Because it runs on most smartphones. And then there's iOS, which is an operating system also made by Apple, but for their phones and their iPads. They provide a nice graphical user interface. When I say a graphical user interface, you can move the mouse around and click on things and bring up a spreadsheet and all that kind of stuff. If every operating system does not have a graphical user interface, if you are using the computer for very basic functions, or it is providing computing power for another computer, then the interface can be very, very basic. And it can be something called command line. So let me just, and command line just looks like if you brought up a Microsoft Word document and you just started typing in it. And that's how you control the computer. That's how you move files. That's how you handle graphics, everything by just typing words. You just have to know all of the commands. Luckily, most people don't have to deal with that. I would have had to deal with that in my job, but luckily, most people don't have to deal with that. Luckily, they can just use a graphical user interface like what you have right now. Linux, just a small note on Linux. Linux is, as I said, it can be used for your desktops and your laptops and so on. But Linux is very, 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 very flexible. So, and it can be very small. It doesn't take up much space. So the little computer that I showed you earlier, just now, that will run Linux. The TV box, the floor box that you have, that runs Linux. The direct TV box, that runs Linux. If you have a smart TV, that runs Linux. Your car, if it has like something that handles Bluetooth for the radio, etc., that runs Linux. Linux is fairly ubiquitous, and because it is so small and easy to set up, well, not easy, let me take that back. Because it is so small and it's free, that's the best reasoning, really. It's small and it's free. Now, for larger entities like banks and governments, they will have these big, powerful computers that people will be accessing data from. Those are called servers. Those of you who play video games know what a server is. That sits at the middle of the game and kind of handles sending out information to everybody who is a part of the game. Those are run by operating systems as well, usually Linux, or maybe something from IBM, something from Windows, or those are the most common. Okay, let me move on. I know I'm not going hugely deep on any of these topics, but if, again, you can stop me if you want. Anybody have any questions so far? Okay, good. Moving right along. Hope that doesn't mean everybody is falling asleep, and but you're still here, so let's keep going. I just want to talk about open source for a minute. Remember, I said Linux is free, right? Linux is actually something called open source. And let me what's the word? Let me contrast that with closed source for a moment. Windows that you have on your computer, typically you will have to pay somebody for the Windows that is installed on your computer. Even if it comes with the computer, the cost of that is built into the computer. The reason you have to pay for it is because Microsoft made it up. Microsoft has created Windows. They don't share that programming code with anybody. They don't share the code that they use to make Windows. And we'll get into code when we talk about development more, but they don't share the code. Every program, everything that controls a computer is written in a kind of code. Microsoft does not share the code they use to write Windows. They close it off from everybody else. Therefore, it's called closed source. And then they make you pay for it. They make you pay for the completed coded product. So like when you buy a car, the car manufacturer may not share with you every single part that they use to make that car. They won't tell you that, the spark plugs are this kind of spark plug, and this is this kind of thing, and the brake pads are this kind, and the axle is this. They probably won't tell you all of that. They won't share with you you can find it out, but they won't share with you the deep makeup of the car. You just buy the car and you use it. Same thing with closed source. You just buy the OS and you use it. End of story. If there is an update to be done, like how you service a car, if something has to be done to fix an issue that was discovered, Microsoft will release the update. If there's a patch to be released to fix a security problem, Microsoft will release the patch, and they will have a way of distributing it to you so that you get it. Closed source costs money, and it is maintained by a company. When I say maintain, the patches, the updates, any fixes, anything like that, the company has to do, because you don't have access to the source, so you can't fix it. They have to fix it. Open source is different. Open source is created by and maintained by a bunch of people who just get together and, online and decide, hey, let's write an operating system. And sometimes it's really, really good. And as the operating system gains popularity, more professionals will contribute time to helping write it. And they, you get thousands, maybe even millions of people working on a single operating system and adding pieces and saying, hey, wouldn't it be better if we did it this way? And they add that piece. And don't we want to add this? And they add that piece. And that sounds really good. And sometimes you get some really brilliant work coming forward. As a result of the fact that 1 million people worked on it, if you're going to pay somebody for it, who are you going to pay? Nobody. You can't pay 1 million people for their work, their volunteer work. So open source is usually free, because 1 million people work on it and then they give it you to download and say, all right, use this here. Linux is open source. Originally, it was written by a guy as a project at school, and some people got their hands on it, and people have been adding to it ever since. And that was like in the 1960s, he wrote that, or 70s, and now it is, it is one of the biggest operating systems out there. The only problem with open source, though. Sorry, is that a question?
Yes, I wanted to ask a question. I'm trying to assimilate the information I give you.
Yes, please.
Would you say that before, when you could download Windows on your Microsoft on your computer, would you say at that time it was an open source?
No, Microsoft
was available to you.
It was never open source. But
okay.
But what they will do is, like, I had Windows, when you had Windows 8, and then they gave you the chance to download Windows 10, or when you have Windows 10 and they say you can download Windows 11, that's an update that they're giving you. And that update is part of what you paid for when you bought the operating system. That's them maintaining it. That is their thing of maintaining the operating system. This is how we do maintenance. We're going to send you an update so that, you will have the newest thing that we have created. And it's in their interest to maintain it.
Okay, but now you is it that you buy it or you don't have it at all now?
So if you buy a computer and it comes with Windows, the cost of the closed source Windows operating system is part of the cost of the computer. And all of the maintenance that comes after that, once you've paid for the Windows operating system as a part of the computer, then you get all the maintenance that comes with that. Okay. All the new versions that come down, that's up to you to download. It's free for you because you've already paid for it.
Okay. Well, I bought my a new computer, sorry, in 2017. I didn't get that option. I didn't get that option.
That's how it's supposed to work. I mean, to be perfectly frank and honest, some people will download a free version of Microsoft Windows, hacked free version, and they'll install it on your computer for you for free. But that is illegal, essentially. And you really shouldn't do that, because in the day that Microsoft ever finds out that, you have a version that is free or that was illegally put on or hacked or whatever, what they will do, they won't charge you anything. They can't charge everybody that has a hacked operating system. But what they will do is not give you any more updates. So if like a vicious virus comes out the next day that eats your computer alive, and it's there's some Microsoft update that fix it, you will not have it. So that's typically how they protect themselves. And and they're closed source licensing. All right, open source, usually free. The big problem with open source is that yeah, I mean, it's free, it's usually good software. What could be the problem? The maintenance of it. If you want a patch or update, you have to go find it yourself. You have to go online and find a patch for a specific problem, download it, and install it yourself. Microsoft will take the responsibility, and Apple, for example, will take the responsibility of downloading and installing all the updates for you. But if you are dealing with open source, it's all at you. You gotta figure it out yourself. I know some large entities that have bought open source software. Government, it was a government that have bought open source software. That was one of they weren't my client, but I was helping them out. And they thought they were so smart when they bought the open source software, but then the one body that knew how to maintain it, when he left the government, then all of a sudden the whole thing fell apart because nobody knew how to fix it and how to maintain it. And as a result, the government, like the prime minister and all kind of thing, ended up having to use their personal email and all kind of thing for stuff. It was ridiculous. I emailed the prime minister a Hotmail address and thing. That was ridiculous. That was funny. But it happened for years, right? So open source is great, but you have to keep in mind that you have to maintain it yourself. What some companies have done, like Red Hat above, is that what they've done, they've said, all right, we will sell you an open source piece of software, but really and truly what we will sell you is not the software, but the maintenance. We will sell you, we will maintain it for you if you buy it from us. All right, so it's open source. Red Hat Linux is a kind of Linux, but they will maintain it. So they will do all the updates, they will do all the patches. So businesses will typically not use strictly open source software. They will use open source software that somebody has committed to maintaining, like Red Hat. So that is an example of that. I hope that was a decent explanation because this could be fairly complicated. All right, only got a few more slides to go. 4 more and a few more minutes. We may end up going over by about 10 minutes today. My apologies because I want to give you all time to do the test. So heads up, telling you no. Office productivity suites. So some of us use Microsoft Word, and what you're seeing right now was done in PowerPoint and so on and so forth. Office productivity suites will have usually 3 parts, at least 3 parts: a word processor, like Microsoft Word and Google Docs, a presentation software like PowerPoint and Keynote from Mac, and a spreadsheet piece of software like Excel or Google Sheets or so on and so forth. Those 3 things will always be in there. I think everybody knows what a word processor is, I hope, where you can write letters and write documents and write sermons and whatever else you want to write. Presentation is for creating presentations, much like what we have here, slides that I'm showing you. And then the spreadsheet is for calculating with large amounts of numbers, basically. Conducting calculations with rows and columns of numbers. If you have to deal with lots of numbers, spreadsheets are where you want to go, at least at a very basic level. Some of the productivity suites will also have email and calendars and cloud storage, but they will all have a word processor, presentation, and spreadsheet at least. All right, moving right along. Client server applications. I'm feeling like this may be a little deep for today, based on our time, but I will just push through quickly. Client server applications. So as I said, your phone is a computer. Your smartwatch is a computer. The little motherboard that I showed you, that's a computer. All these things are computers. But there are applications, there are things that you will run that are way more powerful than what your phone can handle, or what this little floor box that you have can handle. Netflix, for example. Netflix is It runs on your phone, it runs on your tablet, it runs on all these things. But the reality is, if you look at the amount of data that Netflix must have, the amount of movies they have, you know, you can't hold all of those on your phone. You do not have those on your phone. They are not on your phone. All right. So they have to be somewhere. And the way client server applications work, and this is why they were invented, there is a server, a computer, a big computer sitting on the back end somewhere in the world that handles all of that heavy lifting and all that heavy processing. All of those movies are stored on a very big computer, and that computer talks to millions of people who have Netflix. And when they request a movie, that computer is smart enough to go and find the movie and send it to that person's device. All that person's device has to do then is receive the movie and play it. So that is how client server applications work. Netflix has a client that sits on your phone, and there is a big Netflix server or set of servers sitting somewhere in the world, which has the movies and has the application that sends the movies to people. All right. You don't have that power on your phone, but that power exists on the server. You will call on that power when you want to access it to do something. And the entire internet is built on client server applications. So if you use Gmail, you don't have all of that space on your phone. But Gmail stores the email for you and gives you access to it. If you're accessing Scotiabank's website, Scotiabank isn't going to send their code to your phone. They're not, right? They'll just give you a little piece so that you can access their systems, their servers on the back end. The client is what sits at your home computer, and the server is what sits on the back end. Not every application works like that. So if I go back one slide, your Office productivity suites, unless you're using Office 365 or something like that, if it's local to your computer, it is local to your computer. So there's no backend server for PowerPoint. It just runs on your computer. But for client server applications, there's a backend server somewhere in the world, and there's a front-end client that runs on your phone or your computer or whatever. All right, hope that was a good description. I'm just going to touch on one thing. Remember, I said Netflix has to store huge amounts of data and call it back for you very quickly. That is hard to do. That is very hard to do. So to make it easier for applications to find the data it needs, it stores it in something called a database. And it looks like, columns and rows, much like an Excel spreadsheet or any other spreadsheet. And it stores the information like that so that it can find it quickly. We will touch on databases in more detail when we talk about data and AI, but for right now, that's all you need to know. Finally, my last slide. I'm going to touch on this next week. but no, well, I guess I could do it now, just very quickly. So far, we've talked about computers, we've talked about software and hardware and so on and so forth. What somebody figured out a few years ago is that computers are getting more and more powerful. Remember, I had told you that, you have different cores and threads and all of that stuff. And the CPUs are getting more and more powerful. Computers are getting more and more RAM. And people started to think, every time we want to run a new application, we buy a new computer with a whole set of CPU and a whole set of RAM, and usually it will waste. Usually we buy more than we need and the extra will waste. Some really, really smart person recently, like maybe 10, 15 years ago, said, let's not waste it. Let's take the computer and inside the computer in software, let's break it up into a whole set of virtual computers, pretend computers. Let's take some of the CPU, some of the RAM, some of the hard drive, some of the GPU, some of the networking, and give it to that virtual computer. And let's have like 5 or 6 or 10 or 50 or 100 or 200 virtual computers running in this one single computer. And each of those virtual computers then can handle a different application or a different piece of work. That is the whole idea of virtualization. A single computer being broken up into a whole set of virtual computers. All right. And the advantage of that is that each of those can handle an application. If something happens to that virtual computer and it dies, the rest of the virtual computers will still keep working. If something happens to the virtual computer and the application quits, it will not affect anything else. Whereas if everything is running on one physical computer and one application decides to quit or behave bad, the whole computer is dead. That's it. Computer goes down and you have to restart it. And we've all seen that. If those of you who have Windows have seen what you call the blue screen of death, where a blue screen comes up and there's nothing you can do except reboot the computer. If one virtual computer gets a blue screen, then nobody cares. You just, shut it down and restart it because all of the other virtual computers are still working. Virtualization is extremely common nowadays. Microsoft has a virtualization method, and then the other very popular vendor, let me move my head out of the way, is somebody called VMware, which is the one below. Those are the two main virtualization vendors. All right, that's a lot of information. A lot of information. I have here some certifications that you can dig into if you want to go a little further. There's some Microsoft fundamentals certifications. They have free courses, but the exams are paid. So the exams cost 99 US each, but the courses are free. So you can go and do a Microsoft fundamentals course now in an area that makes sense for you for software. But the exams, if you want to get certified, the exams are paid. Linux Foundation, very similar thing. If you want to learn about Linux, understand Linux, learn Linux, is free and is extremely powerful. You can go and get free courses from the Linux Foundation at these links, but you have to pay for the certificate. So it's much like that. Pay for the certificate, pay for the exam. Apple, free courses, pay for the exam. Same thing. So I have some links here to some of the free courses with the paid exams that you could look at. I am now going to bring up today's test. All right, because it's quiz time. Here's the quiz time thing. I'm going to bring up today's test and I'm going to give you, it's 15 questions and you have 10 minutes. So I'm going to give you 10 minutes to do this test, after which I will shut this test down. And go. How hard is it? I'm sorry, the questions are hard. Oh boy. Just while you're going through the questions, I see a question here about a Fire Stick. A Fire Stick is a computer. Yes, it is. And a Fire Stick, if you open it, will have a CPU, it will have RAM. And it will, well, kind of RAM. It will have some kind of storage and it will have a CPU. Yes. Sorry to disturb you. Let me let you go.
Sean,
Yes.
my
Hello.
thing stop. Just the one question came up there. Can you see anything else?
Uh-oh. You need to scroll down. The other questions, when you scroll down, the other questions are there. All right, we have 6 minutes left. Well, 6 minutes left. Sister Bradford, you got through? Might take that as a yes. We have about 5 minutes left. Might probably do last time next time. My impatience is showing again. 4 minutes left. I'm seeing answers starting to come in. Okie dokie. We have 3 minutes left. Is anybody not done? If you're not done, raise your hand. Because I think we can probably close it off now. Okay, I don't see any hands, so I assume everybody is done. So I'm going to end the poll now. Okay, and I'm going to share the results. And let's go through. Okay, so we have the correct answer for number 1 is the CPU is the brain as opposed to the navel of the computer. RAM often overheats. That is not true. RAM does not overheat. Your CPU will overheat, your GPU will overheat, but your RAM and your storage and stuff will not overheat. It doesn't need its own fan. 1 gigabyte is how many megabytes? That was a hard one. So I can't really be vexed with anybody for getting that one wrong. But it's 1,000 megabytes. 1 gig is 1,000 megabytes. And the way to kind of figure this thing out is that it goes in thousands. So if you ever see 100 or anything, so it goes down. Solid state drives are faster than hard disk drives, for sure they are. Hard disk drives have moving parts and they're slow. Solid state is much faster. HDMI is for video. Everybody got that right? Yes. Match the hardware and the software. CPU is the brain of the computer. The RAM is the short-term memory. SSD is the fast long-term memory. The motherboard connects all of the elements, and then the GPU is used for graphics. So there we go. A smartwatch is a kind of computer. Yes, yes, it is. There are lots of different types of computers around you, especially nowadays, now that we, doing a lot of these things. Which of these are operating systems? Microsoft Windows is an operating system. Linux is an operating system. Office is not an operating system. That is a productivity suite. And we talked about those a little while ago. Open source is usually free. That's the big thing about open source. It's usually free, but it's not really very well maintained because, it was written by lots and lots of people. So getting fixes for it is at your own risk, really. An Office productivity suite will at least have a spreadsheet, word processing, and presentation application. They'll have those three at least. Microsoft is not the only provider of Office presentation suites, so of Office productivity suites. So, Microsoft Outlook would not be the right answer for that one. Gmail is a client server application, most definitely. There's no way you can hold all of that mail on your phone and all of those features and capabilities on your phone. Gmail, the real processing happens somewhere else. You are just shown a visual representation of what it looks like. That's the client. But then the actual hard work is done by a computer somewhere else. So, and that's the server, so client server. Most server applications will have a database, yes, because like Netflix, for example, will get very confused if it had to manage, hundreds of thousands of movies and they're just sitting down on a hard drive someplace. The database will organize it in rows and columns and make it a lot more easier to manage. Virtualization lets you take many virtual computers and join them into one physical computer. The other way around. Lets you take one physical computer and turn it into many virtual computers. Which certification vendor is most recommended for hardware? If you remember at the end of the hardware section, CompTIA was the only vendor I gave you guys. They're the biggest for hardware. And then USB stands for what? Universal Serial Bus. You either remember that or you don't. All right, let me show the correct answers here. And I will stop sharing that. Sorry, that was pretty quick. Was that too quick for people?
That was real fast.
All right, my wife said that was too fast. Wait, let me go back. Let me share the results. There we go. Back in stream. We give you all a couple seconds to look through. See how you did. My wife here looking at me nasty. Sorry.
Well, I did more than I did my expectations.
You know what? That's good. Oh, that's good. Next week, we are going to deal with networking because computers are all well and good by themselves, but realistically, there's not a whole lot you can do with a computer that's just sitting down and isn't connected to anything else. Most of the things we use, like email, the internet, and pretty much all of the services that we use require us to connect to some other computer somewhere. So how do those connections work? Networking is what we're going to talk about next week. And again, my intention is to give you not all the information in the world, but enough information to decide whether or not this is something you would like to go into for a real life job or career. All right. So we talked about hardware and software today. This is mostly from the computer technicians side of the house. Next week, we're going to talk about networking, where you're going to, that's more a network engineer or a site reliability engineer, reliability engineer side of the house. So we'll talk about those, about networking and those types of capabilities from next week. Take a look at the certification links I sent, especially the free courses. And if there are any that interest you, please feel free to take them. Because it's a really good way of broadening your knowledge and getting, if you take the certification and actually pass the exam, then you have something you can put behind your name and show people that you know what you're talking about. All right, that is it. Have a great rest of the week. God bless. Goodbye, everyone.